from Electronica 24. It's Michael from Embed here, and I would like to tell you a bit more about what we've been showing here, because there's an exciting update in what Embed can do. So, let me tell you a bit more. Imagine you are building a new device, and you have a bunch of chips you want to choose from. You have, let's say, an accelerometer you need to integrate, and there are options from analog devices, ST, TDK, and you don't really know which one is going to perform best for your specific applications. So normally what you'll do is you'll go and try to find an open source library or put together a driver, integrate it, or in a larger organization you'll go and actually ask for firmware team to put together some basic drivers and integrate it. So what Embed allows you to do now is to validate chips easily without any coding whatsoever. How does it work? So first thing you do is you get the actual product that you are trying to integrate. In this case, an accelerometer here. We connect the accelerometer, we take the dev board for that accelerometer that ideally we would like to use in our project. So the dev board I have on my table is STM32F4 series, and we're going to be playing with that. So the first thing I'll do is I'll actually go and upload the datasheet for the component that I'm configuring. As we upload the datasheet, we are able to pull all of the information that's relevant for firmware integration of that product into our digital component model. That digital component model is configurable. So as you can see here, you're able to set up your bus, select which interface you want to use, I2C or SPI. Let's say I2C, you can go and select the frequency you want to use. For your project, you can select address where it's connected. We can then go to register mapping. In the register map, we extracted all of the registers this device supports. You can go expand each register, see addresses, sizes, and all of the other information. So here, even bit allocation, constraints, and their values are here as well. You can make any changes here, drag and drop style. All of this information is backlinked to PDF. So if you need to, you can just open the PDF button here, then select backlink mode, select the data point you are looking for, and it will pull up the information that you need right there. So let's say we are happy with registers, we have all the data types, events. We can quickly set up initialization. So you can select registers here that you want to initialize with. Let's say this config. We select that, let's say this 3, and then we can actually, for each register, select which one we want to use and which mode we want to initialize it in. So here, I'll quickly adjust this. For this gyro, I'll be able to quickly adjust that as well. And you can also change the sequence at which you want to initialize this. So let's say we've done that, we've set up the component. What do we do now? So ideally, I just want to quickly see if this component works whatsoever. So I go to targets, and I select the dev board that we have on our table. And in this case, it's our Nucleo F413. So I type that into our system, and then it pops up. As you can see, we select that specific board, and we click connect. Now the board is connected to our system. This is actually physically wired to it. I go to test now, and I click flash. At that point, what we do, we essentially generate the driver for that chip in Zephyr, and we integrate it with board support package that's available in Zephyr for this specific product. And now we can see all of the registers and live readings for each one of them. So here for accelerometer, as you can see, if I move this, you see that the values are changing. So you can quickly see whether the product is working and read out all the values. If you open that, you can also see what exactly happening. So here we have default 0, it read 1. What does it mean? Here, interrupt occurred. Pretty straightforward. Amazing. And if you are happy with that, let's say you're a hardware engineer, you've checked it, you've checked multitude of other chips as well. Let's say this TDK is the best one. You then go and send this to your embedded firmware team. They open it. They have their configuration already set up for them. They can just select a target where they are integrating this chip, so the actual HAL architecture that they have. They select it, and they can quickly generate a driver library, a full library that they need to integrate that chip into their project. Great, so that's pretty much it. I hope you liked it, and yeah, stay connected. Thanks a lot. Bye.